So the next thing I'm going to work on are these reinforcing strips underneath the side doors, and I'm going to finish with this tongue thing. What I have here is just a regular spike, about 3/8 of an inch long, and that's going to go inside the small tube, and that tube is going to go in here by me drilling a hole in there. And let's see, the spike has to go back pretty far, so almost all the way through all that styrene. And I might only drill this just a little bit back, and then I'll just use a small hole and I'll stick that in the hole. This is just used to represent this little thing that sticks out. It's the coupling that fits into the adapter truck, and it provides both the mechanical connection as well as the air brakes and for the air motors. So it's a pretty interesting arrangement. Now to drill this hole, the outside diameter, see, I'm just rotating this because this tube might not be perfectly round, might be a little oval shape. So more accurately, I can lightly put pressure there and then turn the tube. And I'll take the biggest size, which is right around there, it's like 95 thousandths. I'll look for, here's a 93 and a 96. Try the 96. That doesn't give a whole lot of clearance on the sides. Oh, that one won't work. This one, yep, okay. Now before I go drilling into this, I kind of want to make like a little test hole to make sure that that rod will fit. So we take a piece of scrap, another great use for these. I can just drill this hole. Now there I've got just a maybe 100 thousandths deep, and I want to see how well this fits in. So I push this down all the way and rotate it, and because this is all white and it's hard to see, I'm just going to rub a pencil right along there, so when I pull it out I know that's how deep it went. So in fact it did go the full distance, and I think that's a good fit. I could try to use that 93 thousandths, but honestly I don't think it's really worth it. So trying not to move the drill around. If you have a drill press, that would be ideal. But just trying to keep this hole vertical, not just to make it vertical, but if I move the drill bit around as I'm drilling it, it's going to make this opening bigger. Yeah, that's okay. Yeah, I'm satisfied with that. And I don't want this opening to be too big, or else glue will squeeze out, and it'll be a gap, and it just won't look right. So let's gather all my shavings. There's shavings and scrapings that I've collected over the years. When I did some scratch building, I generated a lot of those shavings because I would scrape the edges of the plastic and they get those little curly Q things. Okay, so with this being 93 thousandths or 95, 96, that's just about how wide this face is. And I'm not really crazy about that. If I drill this hole, you're probably going to see kind of like little shapes like that on either side. And if it's equally spaced, they'll be the same size, but they'll be pushed out a little bit because that thin wall is so weak. It'll push out rather than cut. So that's a little problem. I'm going to solve it by filing this down to a bigger diameter or bigger square, bigger cross section. So I just want to draw a reference line on there. Take file. There's no need to do this freehand. If I hold this down and I rest my hand on the bench, I can get a pretty vertical. Once again, line the trailer up there, and I can just sort of eyeball down, and I'll know I'm in the ballpark. Whether I'm 90 degrees to this. Okay. Now see, that didn't, I don't think it didn't detract from the overall look of it, even though it might be a little bit thinner, a little bit shorter, but not by much, so that's okay. I'm still maintaining the close enough, good enough rule. To make sure this looks enough like an accurate model, even though it's not 100% accurate. There we go. Now what have we got? Yeah, it's still pretty close. It's gonna be close, but we'll see. We'll see how it turns out. Okay, now to get that right in the center, I just want to take a knife, any kind of blade will do, any kind of straight edge. Sorry, just looking for all my knives and things. If you line up the blade on one corner and you line up the blade on the other, just sort of make a little rocket back and forth and make an X. If you can see, there's a slight X there. Same thing with this. Go corner to corner. Just make a quick little rock like that. And what I have is an X kind of scribed into the plastic. and it's just faint enough where the graphite will pick it up. But take a sanding stick, a couple of swipes over it, and it'll disappear. And honestly, when this is coupled into anything, you're not going to see those little edges. So I find that's a great way to get it almost always exactly right in the center. Now to start out this precision hole, I can take a knife, which I know is sharp, it's got a nice point on it, I can just kind of move the knife around until I feel it. I feel it click into one groove, and I move it down and I can feel it click into the other groove. And I just want to give it a quick little turn like that. That's just like a little dimple to start this small drill off. And because I have it, I'm going to use this to verify that, yep, it is right in the center of that X. And using the graduations that are printed on the lens in here, I can see that it is centered within, I think, like 0.02. So I can start off with a large diameter drill. If that's not a good thing, if that doesn't work in a certain situation, I can start off using a smaller drill bit. I can drill a small pilot hole, and the smaller drill, it's a bit easier to steer, so I can steer it around and get it, perfectly vertical and horizontal. And then I can always go just a little bit bigger than this and really try to get it straight and true, like one diameter all the way through, because the smaller diameter might kind of wiggle around and deform that hole. And then as a last step, I would use the proper size, and I would just chase out that perfectly oriented hole at the right size. But I'm going to try to do it with this one drill bit, just because I like to try different things, see if they work any better or any worse. So you'll see me doing the same thing different ways, because I just like to try different things. Okay, now with this drill started, I can take another look at it just to verify. Yeah, that looks good. It's like a little bit high, but the left and right, I think, is the most important. So one thing I noticed when I was drilling the test holes is that this had two nice chips coming off of it, which told me that the drill bit itself is sharp. See, there's two curls. That means each one of the cutting edges here is sharp. So I just want to rotate this around, make sure I'm centered in the tongue, a light pressure. If you get like a long chip coming off of here and it's getting to be long and spinning around, just don't push down as hard. Just kind of spin the drill and take some pressure off and then go back down, and that'll break the chip. And smaller chips are easier to get rid of than the big ones that wind around the drill bit. So I probably go about 2 or 3 revolutions cutting, and then I spin it once to break the chip. That's not bad at all. But it does look like the plastic is real thin there. Wow. Yeah, so there's the pencil line, so I know it goes in at least that far. And what I'm looking here, looking for is a strong joint, a strong mechanical, because this is going to be, you know, coupled onto a few other ones. I don't know what the drag is. These are very light. There's not a lot of drag, but there's going to be some, and I just don't want this to come uncoupled on a layout somewhere. I'm going to drill this a little bit deeper. That'll give me a little bit extra insurance. Now see here, I won't break the chip. I'll just keep turning the drill, and you see how it winds around. You get longer chips that way, so there's fewer, but they tend to get tangled up in things. Okay, so that's in there. This is my chisel point sharpened pencil, so I get a good line. To exaggerate the error, if I put the pencil flat on this surface, you can see there's a little bit of white plastic showing under the pencil mark. But here, where I put the bevel of the chisel down, I get a pencil line right at that surface. It's only a few thousandths, but sometimes that helps. Alright, so that's like, what, about 1/8 of an inch? A little more, a little less. Yeah, 1/29. So 4 thousandths more than 1/8. Perfect. This will be good to glue in. And I want this to be at least, or this to have at least this much sticking out. I can always file it down later. Simple, simple. And because this isn't really precise, well, it's still going to be a pain to try to get glue on there. So here I just put a little bit there. Try to wrap that glue string up. Okay. And to make things easier, the edge I just cut looks more square, so I'm going to use this end and just put a little tiny bit on there. That might be even too much. It's not much at all, but I don't want it squeezing out. There we go. Actually went down further than I thought. No problem. Just sort of wiggle it back out. Yeah, so I can cut that back down. Now, to show you, this spike probably won't fit. There'll be a whole lot hanging out. Yeah, that's way too much to hang out. So when that glue dries, I will I'll measure this up. I'll go, same thing with the tube, I'll rotate it to make sure I have a good accurate dimension for the circle, the hole it would make. So 27. So I'll take a 27 thousandths drill and I'll drill it in, maybe even a little bit bigger. That fit, well, maybe a little bit smaller, so it'll be an interference fit. And that will anchor that in there. Let me just clean up a little bit. I'm going to get on with these things. Okay, to put these little strips in, I was going to use the same method I did here with just a strip and chamfer the sides. But I'm looking at it and I'm looking at videos and it looks like it's an angle iron. Well, I just so happen to have several sizes of angle somewhere. Here's one at 60. Now let's see how wide it is. That might be too wide. Well, I think it's exactly the right size. And I can even cut this little edge down. Now there's a bit of a lip along here, which I'll put against the, so it's recessed back. If I put that angle right flush with this, I don't think it looks quite right. So leaving it behind gives a little bit of a shadow line. So the length of these, again without measuring, I'm just making it rough. It's about a third of the way past the rib. It's not quite half. So we'll go a third of this rib to a third of this rib. Right around here somewhere. I'm not trying to cut it, I just want to make a nick so that way I could pick it up better on here. And I'll just try to find that by dragging it along. Once I have the ballpark, then I could I'll try to find the right cut here. Now I don't want the angle to be in a V shape when I cut it. I want it to be vertical, like sitting like an L. And just by holding this down, that makes a good vertical cut that I can snap off like that. The right length, yeah, it's a good size. Or you can just take a sharp knife, cut it like that. Make sure it's sharp or else you will deform this edge a little bit. It's not too bad, too difficult to straighten back out, but it's kind of a pain. It's kind of a pain sometimes. Okay, so I just want to cut that angle along here. So it's going to be chopped off this way at about see what's the best way to cut these. Probably put it in there and chop it off. I'd certainly use the knives, or I can just use these side cutters. And well, it looks like that chamfer goes right down to the edge of the post. So to keep things looking proper,